All right, so as a senior metallurgist, one of the things I get to do is look at our core technologies. And today, we're digging into a really fascinating rivalry in gold extraction, one that's been going on for over 100 years. It's really a classic story, right? Two totally different philosophies trying to solve the exact same problem.
So, here's what we're gonna cover. First, we'll lay out the big challenge we're up against. Then, we'll meet our two main players, the super precise chemist and the, well, more rugged trapper. We'll pit them against each other, see where each one shines, and then we'll try to look into the future a bit.
Okay, so let's jump right in. Before we even talk about the solutions, you've got to understand the sheer scale of the challenge. I'm talking about a problem that every single gold mine on this planet has to figure out. Yeah, this is the big one. It's the question that really defines our work. You've got this massive volume of liquid, and somewhere in there, microscopic gold. It's there, but you can't see it. How in the world do you get it out? It's the ultimate needle in a haystack problem, and over the past century, a couple of very different ways of thinking have popped up to solve it. You can really boil it down to two main ideas. The first one is all about brute chemical force, forcing that dissolved gold to become a solid again so we can actually grab it. The other approach, it's more about trapping it, making it stick to something. All right, let's meet contender number one, the chemist method. And I want you to think of this one as the surgical approach. It's all about pure chemistry, a really delicate dance of precision and control. And look, it's been a cornerstone of the industry for a long, long time, for a very good reason.
So, what's the logic here? Well, it's actually pretty classic chemistry, probably something you remember from school. It's what we call a displacement reaction. We introduce a metal that's way more reactive than gold, in this case, superfine zinc dust. That zinc really wants to be in the solution, so it basically just kicks the gold right out. It forces the gold to precipitate, to turn back into a solid that we can finally see and collect.
Okay, but for all its elegance, this method has a massive weakness, a real Achilles heel. It's a perfectionist. The solution has to be incredibly clean for it to work. We're talking less than 5 parts per million of suspended solids. Even a tiny bit of gunk can throw the whole reaction off. And trying to get something that clean in a mining environment, well, you can imagine, that's a huge operational headache. And that need for purity is exactly why the process is so involved. You can see it's this super meticulous sequence of steps. First, you filter, then you have to pull out all the oxygen. Then you add the zinc, let it precipitate, and then you filter it all over again. There are absolutely no shortcuts here. Every single one of these steps is absolutely critical. Okay, so if the chemist's method is the surgeon's scalpel, our next contender, well, it's more like a sledgehammer. Let's talk about the trapper's method. This one takes a much more, let's say, rugged and direct approach to the exact same problem. Now, this isn't a chemical reaction at all. It's a physical process called adsorption. We use the stuff called activated carbon, which on a microscopic level has a huge surface area full of all these little nooks and crannies. Honestly, the easiest way to think about it is just as a super sticky trap that we throw into the mix to literally catch the gold. And this quote right here, it just hits the nail on the head. It's not afraid of getting dirty. That's its single greatest advantage. Unlike its high-maintenance competitor, activated carbon just doesn't care. You can chuck it right into a muddy, impure slurry. It completely skips that whole intensive clarification step we just talked about. From an operations perspective, believe me, that is an absolute game changer. And the process itself really reflects that rugged, direct philosophy. It is just brutally effective. You mix the carbon in, you let it soak up the gold, you screen out the carbon, which is now loaded with gold, and then you send it off to have that gold stripped back off. It's just a much more straightforward path. So we've got these two very different contenders on the table. The big question for us as metallurgists is, how do we choose? This is a decision we're making all the time, and it really just comes down to picking the right tool for the specific job that's in front of you. This table does a great job of laying out the key differences. And I want to be clear, it's never about which one is better in a vacuum. It's all about which one is better suited for the particular ore that we're trying to process. One is a delicate chemical process that needs a clean liquid, and the other is a tough physical process built for dirty slurries. So here's the bottom line, the takeaway. If your feed is a nice, clean liquid, especially if it's coming from a high-grade ore that also has a lot of silver in it, you're going to be leaning toward Merrill-Crowe.
But if you're dealing with a muddy slurry, a lower grade ore, something with a lot of impurities, activated carbon is almost always going to be the more practical and honestly, the more economical choice.
You know, it's wild to think that these two technologies have been going head to head for over a century. They've both been tweaked and improved over the years for sure, but their fundamental philosophies haven't changed a bit. And that brings us to one final forward-looking question that we're all grappling with in the industry. So after more than 100 years of competition, which of these two do you think will own the future of gold mining? I mean, on one hand, logic might point to the rugged trapper, right? Because we're processing more and more low-grade, messy ores. But chemistry is always advancing. What if there's a breakthrough that makes the chemist's method tougher, more forgiving? Or what if an entirely new contender shows up and changes the game completely? That's the strategic chess match we're playing every single day. This duel is far, far from over.